Okay, YouTube, let's finish chapter 3. We're in section 5. All right, so the exercises, I got the wrong thing. Where's my sage? There it is. The exercises go like this. All right, so this is Computer Science Honors, chapter 3, section 5. We're talking about, all about arguments in a function, right? And then your name, Mr. G, that's me. Don't put your name. Don't put your name as Mr. G. You're not Mr. G. That's me. Okay, so the first question is really not really about arguments. Well, I guess it is about arguments. Number 1 says, what does this operator do? All right, so let's find out. So let's make a function, and we found out that it has to do with dividing. So we're going to say find div of x comma y. And we're just going to return x / y. Aha, and see what you get. Okay. Let's think about this. So what are we going to show? We're going to show what find div of 3 and 2 does. Okay. And we figured out that it's the integer division. So what's the quotient of 2 into 3? How many times does it go in? It goes in once. So that should be a 1. And it is, okay. But then we found something strange. What if we did it with negative numbers? All right, what about negative 7 and 3? All right, so let's do negative 7 and 3. Negative 7, whoops. Negative 7. Did I want negative 7 and 3? Yeah, I did. Negative 7 and 3. All right, so if you did positive 7, div 3 would go 2, remainder 1, right? So is it 2? No, it's negative 3. What is that? All right, so this is what it does. It does a decimal version of division, right? So what's negative 7 divided by 3? It's negative 2.3333, right? Negative 2 1/3. Then it says, okay, I want to return an integer because the div gives you an integer quotient, right? So it does the greatest integer function. So what's the greatest integer you can name less than or equal to negative 2.3 repeating? And it's negative 3. That's it. That's why. But then what's the remainder? Then you got to figure out the remainder so that negative 7 divided by 3 is negative 3 plus the remainder over 3. What is that? Well, we figured out by doing this again, but using a function we made called find mod, which is the percent symbol. And let's see what we get when we do find mod. Whoops, modulus. Instead, let's run the same inputs, same arguments, so it is about arguments, but with the find mod function. So is it true that negative 7 divided by 3 is negative 3 plus 2 over 3? Negative 3 plus 2 over 3, or negative 9/3 plus 2/3 is negative 7/3. That's why. So it gives you the negative 3 based on the greatest integer function, and then it sort of fudges the remainder. Here, this is normal, right? In other words, 3 divided by 2 is 1 plus 1 over 2, right? So the numerator divided by the denominator is the quotient plus the remainder over the denominator. That's the fundamental theorem of arithmetic, right? So maybe we should write that. Let's write that. Let's write that in a comment. I'm trying to make less comments and less numberings. Make it less cluttered in the input and the output, right? But let's throw in one more comment. We're going to say what's really happening is an integer numerator divided by an integer denominator is going to equal a quotient plus a remainder divided by the denominator. That's what we're having. Okay, so we got to figure out a quotient and a remainder such that this equals that, and the quotient is normal. It was what you would normally get from integer division, like in first grade, right? If they're both positive, but if they're different signs, got to use the greatest integer function. Use floats first. That's a little weird, but there you go. All right. So let's show a blank in our output, and let's put a blank in our input. Show number 2. All right, so what was number 2 about? 2 says, what does single slash do? What does a single slash do? All right, so we did, we redefined find div but with a single dash. So I'm just going to slash. So I'm going to do this again, but with a single slash. What's the difference? Let's find out. So single slash. So I just redefined all of this. All right. And it's 3 divided by 2, or it's negative 7 divided by 3. But be careful. That's because I'm in Sage, not in pure Python. Sage gives you simplest answers, answers in simplest fractional form, exact form. But if you did this in Python, it would say 1.5 and negative 2.3333, right? That's what you would get in Python if you did this, like, say, in idle or in Trinket, right? But here we're getting an exact answer because we're in Sage, a computer algebra system. So that's your normal divide, 1.5, negative 2.333, your float divide, right? Okay, that's what that is. Okay, so that's all there is to that. And let's do a blank show in the output. How about a blank line in the input? Show, just make it easy to read the input and output, right? Show number 3. All right, number 3 says, what was 3 about? Can you write a function that finds the arithmetic mean of 2 numbers? Okay, so find the arithmetic mean, and that's just your regular average. Add the 2 numbers and divide by 2, right? Or if it's more than 2 numbers, you divide by that number of numbers, right? But here, they just want 2 numbers here. So how about define, find mean, is that what we called it? Yeah. Of 2 numbers, say A and B. And all you're going to do is return quantity A plus B over 2. The trick here was people forgot the parentheses. So it's going to divide only the B by 2, then add on A. That's not what you want. So that was the issue here. So if we show a test of that, let's see. Let's find the mean of 5 and 10. Well, what's 5 plus 10? 15 divided by 2, that's going to be 7.5. Okay. So let's do quote, quote, comma, find the mean of 5 and 10. Let's see what you get. And you should get, what, 7.5. And again, it's giving me an exact answer. So how do you make it a decimal if you want? You can override that by putting a .n on the end if you want. We call that n-ifying in Sageland. That's not a word. Don't tell your English teacher, right? 7.5. Or you could put it in the n function. You could say, you could do this instead. Just put what you're calculating in an n function. This does the same thing. So use the associativity operator associated with this thing or that. You should get the same thing, either way. So if you want a decimal, do one or the other. If you don't care about decimals, leave it. That's fine. All right, that was number 3. Number 4. What does this code do? So they're just giving us some code, and we're going to see what it does. All right. So here's number 4. Come on. So a blank show in the output, a blank line in the input. Show number 4. Whoops. Quote. What does this code do? Okay. All right, so all he did was he said, okay, A is initialized to 1. B is initialized to 2. Then it says define swap, a swap function, of x comma y. And what it does is it says temp is assigned the value of x. Semicolon means this could be a new line. All right, so this is going to be 3 lines in one. X gets assigned the value of y, and y gets assigned the value of temp. So why do we need a temp? Because we actually want to swap the 1 and the 2. I can't just do x equals y right away, because then it'll write over what's in x, and we'll lose that information. So temporarily put the x value in temp, then write over x with the y, and then in y put in the temp value, which was x. So this is supposed to be swapping the 2 values. Does it? Let's find out. Okay, so, and there was, this is number 4. Let's see. Okay, it says also to return a list of the new x and y values. Okay. Okay, so let's show what happens when we swap A and B. All right, so A is 1, B is 2, right? So let's do quote, quote, comma, swap A and B. A is already 1, B is already 2. What happens if we do that? All right, so number 4. So it swapped the 2 and the 1, didn't it? Well, but wait, did it? What if we show what A is and what B is after the swap? A equals A, and let's show comma, B equals B. Let's see what happens. So A is still 1 and B is still 2. It didn't swap. It only swapped the local variables of x and y in the function. It didn't touch the global variables. That's what that was about. Okay. All right, so number 5. How would you fix it? Could you fix it? Well, instead of throwing in a couple of ints and spitting out a list, how about we throw in a list? A list is mutatable. It's mutable. So let's try this again. All right, so this is going to be number 5. So here's a blank show in the output. Blank line in the input, show number 5. Can you fix that code, the code above? So it does actually do the swap. All right. Okay, so this is what we came up with. Let's see, number 5. We said let's define a function called swap. So I'm overriding my swap method. It takes as input a list. I'm going to call it my list. And we're going to do the same thing we did before. Temp becomes my list. Well, what happened? My list sub 0. Whoops. So we don't override the 0th element. Semicolon. Then my list sub 0 takes on the value of my list sub 1. This is basically the same thing we were doing before, but just with elements of a list. And then we're going to take my list sub 1 and store in there the temporary value that we stored initially, which was my list sub 0. And again, we need the temp so we don't override stuff. By the way, you could write this in 3 lines instead if you want. You don't need the semicolons. All right, so let's say we start this with. Notice this is a procedure. There's no return line. Let's do a pair. Let's define a list called pair. Just making that up. How about a pair with 3 and 4 in it? Okay. And then let's show what it looks like before we run the swap method or the swap function. But then we're going to swap. We're going to call swap with pair, which is 3, 4. Okay, so pair is the local parameter name, and the actual parameter name is my list locally. And then let's show if pair changes at all. So pair is a global variable. Does it change to 4, 3? That's the question. All right, let's see. Yep, it did. So if you want to mutate a list of numbers, make it a list, right? The list type is a mutable type, mutable class. The list class is a mutable class. So show a blank. That was good. We're done with that. And a blank line there. So notice how we're doing this. We're sort of breaking up. There's number 1, then there's number 2. It's easier to see where number 2 starts, where number 3 starts, where number 4 starts, number 5 starts, like that. And the same thing with the output. Here's number 1, then here's number 2, here's number 3. A lot less numbering, so it's less cluttered. Number 4, number 5, just a different style I'm adopting lately. All right, so show number 6. All right, what's number 6 say? Why not do it this way? All right, then they said, why not do this? Why not this as a fix? So they actually give us this code. And let's see why this is not actually what we want. So they defined another swap function. So we're overriding the swap function again. Let's say with my list as the input parameter, or the argument. And so what it does here is just simply returns a list comprised of my list sub 1 followed by my list sub 2. Sorry, sub 0. Because we only have a 0th element and a 1th element. That's not English, I know. And so what if we do the same test? Does it work? And again, this has a return statement, so it is a function, not a procedure. And let's see what number 6 does. So pair before and pair after. Nothing happened globally. But where's the output? Oh, we didn't print it out. Okay, we should print it out. So I should also print out, I should say, show what swap pair returns, right? So I'm going to say what the swap pair return. So we can see the return statement. Or the output, right? All right, let's see about that. So here is pair before. Here's the output of the swap function. Here's pair afterwards. So what happened? They didn't really swap because it's just returning a new list made up of the numbers in reverse. It's not changing the list. It's making a new list. Oh, okay. So that's different. All right. All right, here we go. Number 7. So that's why it doesn't work. All right, so here's a blank blank. All right, so let's show number 7. All right, what was 7? How would you code the quadratic formula and call squirt only once? Okay, so code the quadratic formula calling math.squirt once. All right, so we defined a function we called it quad, call it whatever you want. The input is, quad for quadratic. The input is the coefficients of ax squared plus bx plus c equals 0, the quadratic equation we're solving in standard form, a and b and c. And then we said, okay, why don't we where do we call squirt? Remember, it's negative b plus or minus the square root of the discriminant, which is b squared minus 4ac, all over 2a. So how about we say, okay, I call the temp equals the squirt. Now remember, in Sage you don't have to do math.squirt, you don't have to have the import math, any of that stuff. Math.squirt of b squared, why don't we do this Pythonically, minus 4 times a times c. All right, that is the square root of the discriminant. And so root 1, isn't that just going to be, the numerator is negative b plus that temp, whoops, all over 2a. Be careful, we figured this out in class, it's got to be 2 times a, otherwise we're dividing by 2 and not dividing by a. That's a problem. And then root 2 would be the same thing, negative b, but minus that temp value with the square root of the discriminant. The discriminant is b squared minus 4ac. Remember, we had 4 cases of discriminant. What if the discriminant is negative? We get complex roots. What if the discriminant is 0? We get real rational equal. What if the discriminant is a positive perfect square? We get real rational unequal. What if the discriminant is a positive non-perfect square? We get real irrational unequal. And we tested all 4 cases. We said, okay, what do? We're going to return a list of answers comprised of root 1 and root 2. All right, so we said, okay, show, quote, quote, comma, what if we do quad of 1, 2, and negative 1? I'm going to leave a and b the same. I'm just going to shift the parabola up or down a little bit, changing the c value. What does that equal? Let's find out. So the output for number 7. Right, because b squared is 4, and 4 times a times c is negative 4, so you have 4 minus negative 4 is 4 plus 4 is 8. The discriminant is a positive non-perfect square, so you get real, unequal, irrational roots. Perfect, there it is. And if you want numerical roots, we could fiddle with that, but that's the exact answer from Sage, being a computer algebra system. All right, then we said, all right, what if we change it a little bit? That was real irrational unequal, what if we did this instead? So in other words, this equation is 1x squared plus 2x minus 1 equals 0. This equation is x squared plus 2x plus nothing equals 0, right? So you can factor that in your head. Factor out an x, you get x plus 2. The roots are x equals 0, x plus 2 is 0, x is negative 2. So real, rational, unequal. Why? Because b squared is still 4, but 4ac is 0. So 4 minus 0 is 4. It's a positive perfect square. That's when you get real, rational, unequal roots, right? Let's find out. Let's put a 0 here. And like we said, 0, negative 2. Perfect. Okay. Then how do we get real, rational, equal roots? I think we did this. Because that factors x squared plus 2x plus 1 factors as x plus 1, so both roots are negative 1. So real, rational, unequal roots. The discriminant here is 0. B squared is 0. B squared is 4. 4ac is 4. 4 minus 4 is 0. And so is that what we got? Real, rational, equal roots. The same roots twice. And then the last case was the complex case. If we shift it up high enough, make this a positive 2, it doesn't hit the x-axis at all, so there's no real root. And Sage will give me the complex conjugate roots. That's that complex conjugate case when the discriminant is negative. This b squared is still 4. 4 times a times c is 8. 4 minus 8 is negative 4, so this involves the square root of negative 4, 2i, right? So there's your answers, negative 1 plus I, negative 1 minus I, 2 complex conjugate roots. But if you did this in straight Python, in idle, or in Trinket, I think it'll give you some kind of an exception. It doesn't know how to do complex numbers, right? But it can do these. It'll give you a decimal. Negative 1, was it 1.4 something minus 1 is 0.4. Negative 1.4 something minus 1 is negative 2.4 something. You know what the square root of 4 is. Square root of 2 is 1.414 something, right? All right, so there you go. Perfect. That's 7. Okay. What was 8? How do default arguments work? What does that mean? What's a default argument? All right, so let's do a blank show in the output. And let's do a show number 8. How to use default arguments. Okay. So in other words, they gave us this code here. It says define double, which is supposed to return the double of your input, x. Okay. And return 2 times x, right? Okay. But it said, what if we put in a default value of 0 here? What does that mean? That means that if you test it without input, then the input is automatically x equals 0. So in other words, quote, quote, comma, what happens if you do double just by itself? So it should return 2 times 0 is 0, right? Whoops, what happened? Yellow. Right? There it goes. But you can override that value by plugging in something. Like, I don't know, 5. So it should return 10, right? And it does. Okay. So there you go. That was the gist of default values, if you want to do that. Okay. All right, I think that'll do for now. There was a question 9 that we covered in class, but I'm not going to spend time on that because that doesn't really give me much more information here. So I'm going to leave it at that. That's a good overview of Section 5, Chapter 3. So there's the input for number 1. There's the input for number 2. There's the input for number 3. There's the input for number 4. There's the input for number 5. There's the input for number 6. There's the input for number 7. There's the input for number 8. And here's the output for number 1, output for number 2, output for number 3, output for number 4, output for number 5, output for number 6, output for number 7, and output for number 8. And you can see the code for 9 on my blog. Alrighty, if you're interested. There you go. Alright, bye-bye YouTube. Have a nice day. Thanks for coming.